Yep. All right. Okay. Good. So, yeah, even though you can't see me, I think you can see Floor, right? We're having, as Mark was saying, a little bit of technical difficulties today. In either case, we're very happy to see you here for another Serverless Day meetup. Welcome again. Just before we kick off actually with the speakers and with the agenda, we wanted to give you just a couple of small updates. So, as I think a lot of you know, Serverless Days is a global initiative. There's many different type of meetups in a lot of different type of locations. And today, you're at the Amsterdam one. Unfortunately, we still cannot meet physically, right? So we're going to still try to maybe arrange, if everything is safe enough, some physical meetups at the end of the year. But we're planning probably to do a couple of more this year, probably with a monthly frequency, right? So hopefully you can stick around with us still online and keep the community going as well. We also wanted to just give a bit of a shout out to our own event that we did a couple of months ago. So as I think many of you know, we ran a pretty successful conference in May. We had many amazing speakers there. So it was a full day of events. You can see over here in the screenshot that it was 9 hours of live content. So in case you actually want to brush up maybe a bit your serverless knowledge or see maybe different perspectives as well, right? Some talks maybe about Azure technology, Google, AWS technology, then we would definitely encourage you to take a look at our Serverless Day conference as well, which you can easily find on YouTube. We had also a great after party, right? So you can even if maybe just the technology talks aren't your thing, you can at the very least dial in for some really good music as well from our after party there. So with that being said, I wanted to just give you a bit of an overview of what the agenda looks like today. So we're going to start in around 10 minutes or so. We're going to have Dean Bryen from Microsoft give a presentation about serverless on Azure. So he's going to walk us through Serverless Hacking 101 and what how to actually design secure serverless apps on Azure. And then actually, interestingly enough, after the break, we'll have another Mr. Bryen talk about serverless. But this Mr. Bryen, Stephen Bryen, works for AWS, and he will actually be talking about how that works on the AWS platform, right? So you get 2 for 1 today. You get basically both the Microsoft and the AWS perspective, and even from people that are closely related to each other. And as a result, around 8 o'clock or so, we'll also have a bit of a network chat and a bit of a Q&A. The brothers will take that jointly, so you will be able to ask any questions about AWS or Azure or both, and we'll see who answers and how they answer. In the meantime, we also have, what's important to notice is that we also have a Discord chat, right, as you saw on the previous slide. So if you have any questions, if you want to have a further discussion, please join on Discord chat, where you can, discuss and during the meetup, but also afterwards ask your questions. And also very important, even though this is a virtual event, we still want to make sure that you're aware of our house rules and that you're also aware of the code of conduct that we have. So you can, if you're a very modern person, you can pick up your phone and scan this QR code and read our code of conduct. You can also just click old school on the link that's on the right side. But basically it comes down to, be a nice person, treat each other with respect, and let's make sure that this is a fun event for everyone, right? And that's what I wanted to share, at least kind of from the introduction. I think we can, maybe, I don't know who we can see by now.
I would love to intro Dean.
There we go.
Talking to. And I think I have the great pleasure of introducing both of the speakers, and I love this because I'm working with Dean, right? So that's really nice. And Dean is a principal cloud security advocate at Microsoft since August 2018. And he's also a cloud guru instructor. Previously, Dean actually worked at AWS, so it gets more complicated as we go. And he co-organizes the newly founded Cloud Security Meetup in London, together with his brother Stephen, who we'll hear from later. And his talk, Serverless Hacking 101, we'll look at how to hack and ultimately secure serverless apps on Azure through some live demos. Let's hope they work. And we'll also take some time to look at non-HTTP functions and how we implement security for those. So very excited, and Dean, take it away.
Awesome. No, thank you so much for having me. Yeah, thank you for the kind introduction. I'm not sure if you can see me or not because there were some technical issues, but if you can, I'm waving at the camera. If you can't, then I'm still waving at the camera. Yeah, as Flor said, I'm going to talk about how to kind of secure serverless apps today, but I'm going to do it through the opposite side of the spectrum, looking at it from an attacker's perspective and how we might, we're going to break some purposely insecure apps. I just want to start at the beginning by saying that this is an application, this is for anyone on Twitch, this is an application that I own. I have full permission to perform exploits against this application. I did get a complaint to Twitch once that somebody thought I was hacking somebody else's application. So just some clarity that this is my app and I have full permission to perform these activities that you're going to see shortly. So before we kind of start, and this is a serverless meetup, so people are familiar with serverless, right? We're at the Serverless Amsterdam meetup, so people should have a good familiarity. But I just want to clarify some specifics around Azure serverless that if you're not familiar with Microsoft Azure, you might not be familiar with. So I'll start with the typical diagram that we all see around shifting towards the right and giving more responsibility to the cloud provider and less to you. And everybody's seen this diagram before, but ultimately, when we move towards serverless, we're responsible for less. So there's 2 points I want to make there. The first point is that...
Sorry, Dean. Are you sharing your screen right now? Because I still see the video.
Oh, this is let alone the demo not working. The screen. Green. We need to share that. There you go.
Super.
Can you see that now?
Yep.
Awesome. Sorry, folks. This is the thing you've all seen before. There was nothing before this, so don't worry. You've not missed anything exciting. No good memes or GIFs or anything like that. We've all seen this diagram before where the cloud provider takes on more when we look after serverless. And the 2 points I want to make here is, firstly, I think it's really important that we understand that I'm going to show you how to break serverless apps, and you could leave this with the perception that, oh, these serverless apps, they aren't very secure, right? These are things that they're so easy to break. Well, it's actually the opposite. There's actually less that we have to look after and less that we have to worry about in serverless. So they're actually inherently more secure than traditional applications. So I want to kind of emphasize that. I don't want to leave here thinking, wow, we broke all these serverless things and serverless is bad. It's not. It's great. So I encourage you to, to bear that in mind as we go throughout this. But the other point here is that the two things that we really care about in our application is our configuration and our code. So as a serverless application, they're the two things that we're kind of in control of and we really care about. So our application logic and our code, we need to make sure that that's secure. And we also need to make sure that our configuration is secure, how we configure our resources in the cloud. We need to make sure that that's done in a secure fashion as well. So things that might be different in Azure. So here is a grayed out slide of all the serverless wonderful things that there are in Azure. And these three things in the middle here, you have event grid, logic apps, and functions are the truly kind of serverless offerings. And everything around the outside kind of helps us make all up serverless apps. This particular talk today is going to focus on Azure functions. We only have 45 minutes. I run full-day workshops on serverless security. We don't have time to go through all of the stuff, so we'll focus on functions for this particular thing. So people that aren't familiar, and hopefully you are, but if you're not, Azure functions or functions as a service is us being able to run our own custom code or logic in response to events that happen. This could be a HTTP request, a storage blob being added to storage, or something like that. And this will all, if you're brand new to serverless, it'll all come together shortly. But what is different about Azure functions? Well, if you're using AWS or Google Cloud Functions or something like that, there's a slight difference in the architecture of a function in Azure, which is quite important from a security perspective for someone to understand. So in Azure, everything lives in a resource group. That's like a logical grouping of stuff. It's awesome. It means for me, when I build these demos, I can just go delete the whole resource group afterwards. It's a bit easier than tagging, but that's kind of like the logical container of our stuff. And then functions in Azure, rather than just being completely independent as functions, your functions, these little bits of code that respond to events, reside in what's called a function app. And the function app is the ultimate container or the underlying host for the functions that reside upon it. So this is important for a number of reasons, because here you can see that we have function A and function B. These are HTTP functions with methods here, get and post methods. These particular functions both run on the same function app. So that means that they share a number of things. So now you're starting to think from a security perspective, this is why you need to understand this, right? Because function A can access the source code of function B. They share a /temp directory for storing temporary files. They share a managed identity, and we'll look at identity in a minute and how that works. They're actually the unit of scale for functions as well. So the actual function app is the unit of scale, not the function itself. So this is kind of really important when we're architecting serverless apps on Azure to understand. This isn't such a bad thing. It's just a different design decision. If you and I were both asked to go and build, I don't know, an airplane ticketing website, we'd probably do it completely differently, right? But we'd both end up with an airplane ticketing website. That's kind of how this works with Azure Functions and AWS Lambda and Google Cloud Functions. They're just all a little bit different because different people have built them, made different architectural decisions along the way. There's some actual benefits to this, actually, because of the scaling thing. If function A gets loads of traffic, it keeps the function app nice and warm, so that when function B gets an invocation, it's already warm and we don't suffer from cold starts. So there are some ways you can use this pattern to help improve performance as well, but you just need to be aware of that boundary. And then next up, we spoke a little bit identity. Now this diagram is horrible. I should draw a new one really, but I didn't even draw this one, so I'm not taking any. I'm not going to take the flak for that. But this is actually for a virtual machine. It was the best one that I could find at the time. But ultimately, the way that identity works in functions is that there is a role, or what's called a managed identity, that the function has or assumes. And then you query the metadata endpoint, the local host on that machine, and you can access some keys to go ahead and use that identity. And depending on what access that identity has, it can go and access Azure services, or it will go and grab some keys from a key vault. So we should be using identities for all of our functions, and we should be storing keys in key vault where possible. So it's basically just an extension that runs on that underlying host that we can ping. So our sample application. So being the lightning hot developer that I am, I've built this really complex application for the talk today. We've got a simple client, and then we have a single function app with two functions. And all this function is going to do is we've got one to add speakers and one to get speakers from a database. So this app is called Speakerville. You can go on it and you can get speakers for conferences and stuff like that. We're storing the speaker data inside a table on Azure Table Storage. And this is just a really simple SQL-based storage that we can query. And it all resides within a single resource group in Azure. So pretty straightforward, right? Basically, we're just having functions, a couple of functions. So they're responding to code. The events that they're responding to, sorry, are HTTP events. These are web-based functions. This is basically an API that we're going to call. So where would a hacker start, right? First of all, he or she would put on their dark glasses, and they would type crash override in capital letters into the system, and then everything would break, right? This is exactly how somebody would go about breaking this application. Well, unfortunately, security isn't as sexy as we might like to think in the movies. It's not as easy as that. In fact, it's a lot more boring. What they will start is with recon or reconnaissance, and in normal person's terms, this is information gathering. So, and I've had to put this in like this really fancy word art to try and make it look sexy and exciting, because it's really not that exciting. It's just information gathering and trying to find stuff out. But I want to start this journey from this serverless application. So we know that there's a serverless application. Well, we don't even know that it's serverless right now. We know that there's a web application. How are we going to go and find enough information about it so that we can leverage that information to actually hack this application? Because that's what we want to get to, right? We want to start hacking this application. So I'm going to head over and to my Postman client, and we're going to start seeing if we can demo this. So here's the endpoint here. I've got serverlesssecurity-demo.azurewebsites.net /API/add speakers. So we're particularly looking at the add speakers function here. And it's a really simple function, right? I can just send that request there. And that's going to take a couple of seconds for the cold start. And then what we're doing, we're adding in a speaker called Dean Bryen, email dean@hello.com, employer Microsoft. This is not my real postcode. This is not my real phone number. Please do not try and call me or sign me up for any apps or anything like that. But ultimately, that's going to go and send that request. That should be done by now. What's going on here? Hey, always fun with a demo. Let's resend that. There you go. So it comes back, it says, thanks for submitting your details, Dean. Now, as a user of this application, we don't really know what this JSON syntax is here, what we need to send, like what the actual application is expecting. But let's just imagine that I'm a much better front-end developer than I am, and I've built this fancy front end, and we've done inspect elements in the I'll try and make this, I don't know if I can make this bigger, there you go. And we've done inspect element in the browser, and we've seen that this is the JSON body that's being sent to the backend API from our beautiful Speakerville front end that doesn't actually exist, but we can pretend, can't we? We might have also got this from like a swagger.json file or something like that, looking at or YAML, looking at the Swagger definition for the API, if somebody stored that on GitHub, or we were able to access that. So really all we're doing is sending that. So what have we learned? We've already learned some information already, right? We've learned that it's responding back with this detail, this value Dean, which is something I sent it. So we know that if I send something in this here, it's doing something with that and sending it back to me as Dean. Now, one thing that I always like to test is just to delete the entire body and then send that to the endpoint and see what happens. And we get a 400 bad request, but then we start getting lots of information, right? It's telling us that the property speaker name is obviously expected. We can't read that property. But we can start finding out more. We know we're running on Azure Functions. We've got the Azure Function host workers here. We know it's using JavaScript because we've got an index.js file coming back. We didn't know it was using functions before, by the way. We only had Azure Websites.net, which is a domain that's used for Azure App Services all up, right? So we didn't know specifically. We can also look at the response headers that come back. Oh, sorry, the response headers, not the request ones. And we can see that this server header is returned for Kestrel. So this tells us a little bit of information as well. Kestrel is a cross-platform .NET Core server implementation, and I'm no .NET Core developer or .NET developer, but I believe that's what it does. So that probably tells me that this is running Azure Functions on Linux, not Azure Functions on Windows, because that would return IIS, I believe, if that was running Azure Functions on Windows. So just from running a few requests to this and doing this, what I called it ultimately boring. Hopefully I haven't lost you all yet, but ultimately what we're doing is we're trying to find as much information as we can out about this thing. So let's go back to the slides and see what we've actually learned so far, right? So just from that quick bit of recon, we know we're running Node.js. We know it's Azure Functions and it's running Linux. Oh, we forgot to mention there's no auth, right? We just literally added somebody into the database with 0 auth, right? We've completely forgot about that, right? That's probably a bad thing. Did anybody test this? Anybody see this actually? HTTP, anyone pick that up? We're hitting on the HTTP endpoint. It's not actually enforcing HTTPS, right? These are things that we should check out. And as I said at the beginning, I built this app. Like I know it's bad. That's the point. This is what makes it exciting. And then we know it receives a JSON object, and we know that the code is expecting a value for speaker name. So we can then use that to see what can we go and do. So it's expecting JSON. It's running Node.js. What would we do? So what we do next is we would Google with Bing. And we would look for something like Node.js JSON exploit, right? Just really simple, right? And here, the first post that comes up is that you can exploit this Node.js deserialization bug for remote code execution. Now, as an attacker, anything that says remote code execution is like music to your ears, right? You want that, right? That's the ultimate goal, is we can do remote code execution on the machine. So let's look at this, right? So a quick deeper search. This is actually the research paper from the people that found this deserialization vulnerability. But you can go over to ExploitDB, which is a brilliant service, which is provided by the people behind Offensive Security, or Rapid7 it is, I believe. And you can see here that it tells you what it is, who did it, what the CVE ID is, and all this great stuff. But at the bottom here, it always has a sample, right? So if we zoom in on that a little bit, you can see here that as long as they're using the Node serialize module in Node, which actually gets a couple of thousand downloads a week, maybe a few more, maybe a day, it gets quite a few downloads, and you're doing serialization in Node, you can send in this payload here, which is this bit here, and then as long as they're using the unserialized function of that serialized library and they're passing in the payload or anything, it doesn't have to be exactly this, as long as this is inside the payload, then you should be able to run a remote code. So let's look at that a little bit more. So the bit in yellow here is the actual vulnerability, right? This $ND function. This is what's actually breaking the system during the serialization. And serialization is bad anyway. Generally, unserializing stuff is pretty bad. And then you can see this code is the code, right? So this is actually, we're requiring child process. So anybody that's wrote JavaScript will know this is like doing os.system or something on Python. We can do child process.exec, which means we're going to execute a local command. So we're going to do a command line command, and we're just doing ls here, and then we're logging it out to standard out or something here, right? So really, really simple. So whatever we put in between these lines here in the purple bit is JavaScript code. All right, so this is what we really care about. We can write our own JavaScript code here, and whatever we put in there, our function should execute, assuming that they're using the node serialize module. And guess what? Who built the app again? They might be using the node serialize module. Let's find out. So how do we go about and test this out? So that JavaScript there that we had, we need to work out what that is. So I created a gist, and I can share these links after as well if people are interested to walk through this. So in order to do the remote code execution, one tactic that I like to use is to use ngrok. If people haven't used ngrok, it's a brilliant free open source tool for tunneling traffic from the internet to your local machine. People often use it for local development and stuff like that. But what I'm doing here, number one here is my attacker PC is going to do a GET request to that endpoint, which we just did, right? We did that GET request in Postman a minute ago. We're going to send the body, which has got the malicious payload. The function is going to come back with a 200 and say, yep, thanks, Sally or Dean or whoever it is. I've now got that. I've now got that for you. So this is all good. And then, but also because we're sending in that payload, we can get the function to run whatever JavaScript code we want. So I'm going to get it to use the serialize. I'm going to break out to the underlying function host, and I'm going to send a GET request back to me on my attacker machine on my command and control server. And then I'm going to pass in a query parameter of data. And then I'm going to base64 encode whatever the output is of the command line and send it straight back to that GET request. So I'm sending a request in. Everything looks normal to the user. They get a response back. The Azure function thinks it's run as normal. It responds with a 200. But I'm actually sending back a GET request outbound from the function, and I'm encoding the output in base64. Now, this is all going to become a little bit clearer in a minute. This is what the function code looks like. Anyone who's a JavaScript developer, you can see the function code here. So it's const exec equals require child process. And then we're just going to do a variable called command here that says curl the ngrok endpoint. And then we're going to pass in the data. And inside that data variable, we're just going to run a command line thing and base64 encode it. And then we're going to execute that command and then return. This stops it from hanging and quitting out. So rather than do all of this code, like this in multiple lines, if anybody's ever tried to do this before, it is horrible. See all these slashes and colons, you have to like escape all the characters and go through and do a bunch of escaping. You don't want to do that. So you grab this code, and I just encoded it as hexadecimal. So all that, this line here is basically just that code in hexadec. So then the code that I'm actually going to send here, you can see that syntax here. I've got the speaker name, the speaker surname, exactly the same syntax that I had before. Instead, I've added a parameter to this JSON called naughty. A little bit naughty going on here. What's happening? And you can see this looks familiar, right? We've got the underscore $$ND. This is the payload exploit. And then we're going to run a function, and we're just going to pass that hexadecimal into a buffer and decode that hexadecimal so it runs on the machine. Turn that back to a string, and it should run that JavaScript code that calls back to my endpoint. Now, doing this every time, setting up ngrok and getting the endpoint and pasting it in here and then hexadecimal encoding it is a bit of a pain in the backside. So what I did was, and I can share this as well, I wrote a really simple command line script called generate_payload.sh. You give it your ngrok URL and the command that you want to run, and off you go. So let's show you, let's get to the demo. Let's make this bigger. So what we're going to do this is we're going to run ngrok on port 80 here. So this is actually open to my machine. And then on this one here, we're just going to run a simple HTTP server in Python. So we're serving HTTP. So we've got a web server running here. ngrok has this really nice built-in inspector on port 4040 on your local machine when it's running. If I refresh this here, so all of the packets that come into our ngrok machine, we're going to see here. And then in this one here, I can actually run my script that I created to generate the payload. So let's go back over to here. we're going to export our, we're going to set our ngrok. Where was that one? Here. So this is actually, we're just setting a variable on a local environment variable on our machine to my ngrok URL. There we go. And then if we go back to the walkthrough, you can do something like this, right? /generate payload.sh, and then you pass in a command that you want to run. So I'm going to run env on the, this is actually trying to run a command on the Linux server that is running underneath my function. So I'm actually running commands on function, and then I'm going to grep MSI. So what I'm looking for here is environment variables that include MSI. This is looking for tokens, so I can actually get the key, so I can query the MSI endpoint and get the token. And I'm going to pass it my ngrok URL to it. This is the script that I wrote, and the name has changed, so excuse me. Right, nice. So that's going to generate a payload for this command, and it's going to send it back to this server, and it's all been buffered up for you. It's all been ready. So we just need to copy this here, go back to Postman, and let's do something like, we can just use the same request here, right? We'll look at the body of this request. Oh, no, I can't because I haven't got it there. This one will do. Here we go, Bob Harris. So you see I've got this before. So I just literally add a parameter called naughty at the bottom of that JSON. I paste in that code that my command just run. This is our payload, our exploit. And then I hit send. We scroll down, we see we've got 200 OK. Thanks for submitting your details, Bob. Everything's OK. The server thinks everything's fine. But when we go back to our browser, if we look at our ngrok inspector, we got a GET request. Someone hit our server. I wonder who that was. And you can see here that we have this data attribute that's sent here. So if I copy this data into a base64 decoder, agree to everything, and decode, we can now see what my MSI endpoint is. We knew that that's the same for every function, but we've now got the secret token for the MSI endpoint. So the way that managed identity works is you have to query that endpoint and pass in the MSI secret. So next what you could do is then run the command again, as you can see here. But instead, we're going to pass the header with our MSI secret, and we're going to pass in the endpoint, and we're actually going to go and get the endpoint. Go and get the JSON. This will give us a JSON web token, which will access Azure storage. Now, I could go ahead and do that, but we don't have much time for the talk. So you saw it work, right? I actually ran a command on the underlying Azure Functions Linux host because somebody used a vulnerable node dependency that was vulnerable to a serialized dependency. What I could now go and do is start pivoting, right? I can go and get this JSON web token because imagine that this function has wide open access to my entire Azure account or subscription. I can go and use the identity of this machine. I can get the JSON web token. I can leave the machine and I can just use that token publicly to go and do stuff. But as every hacker or offensive security person knows, that what you really want to do is you really want to get a reverse shell on your machine, right? You don't want to keep having to package up every single command and sending it and then hitting you back on an ngrok endpoint and things like that. That just takes a while. You really want shell access to the underlying function host, right? So the pattern looks a little bit similar. We're going to do a GET request to serverlessdemo.azurewebsites.net. We'll get a 200 OK back. But this time, we're going to get it to do a TCP connection back to our machine over ngrok. And doing a TCP connection means that we can set up a listener on our machine. So rather than a web server, I'm going to set up a listener on a particular port. I'm going to tunnel that using the ngrok, and hopefully we can break open a reverse shell. So on my machine, I'll have shell access to the Azure Functions server that's running in the cloud. You can't even do this in Azure, by the way. The reason I found out how to do this, just for some interesting fact, is that on Windows-based Azure Functions, you can use Kudu, if anyone's familiar with that, and you can get access to the shell and you can actually do it in the browser. That functionality isn't available on Linux functions. So I was like, can I get a reverse shell? So I started doing some research and yeah, lo and behold, managed to get a reverse shell on my function. So that helped me navigate and understand what the underlying Linux system looked like. So let's go and try and get this reverse shell, because this is what we're really here for, right? So we're going to cancel this ngrok. We're going to cancel this web server. And instead of that, what we're going to do is we're going to do a netcat listener. So netcat is a tool that just enables you to listen on your machine on ports. So I'm using Ubuntu here on Windows Subsystem for Linux. So I'm saying telling my machine to listen on port 3006. And then on this one here, rather than ngrok HTTP, I'm going to do ngrok TCP on the same port 3006. I'm going to tunnel any TCP connections inbound to that netcat listener that we've got. This is also free with ngrok, but you do need to have an account with ngrok to do TCP connections if anybody's interested in trying this out. So now you can see that we're forwarding 0.tcp.ngrok.io 10542 through to localhost 3006, right? So this is a public TCP endpoint. All we really care about here is the port, because you guessed it, I've made a tool that generates the reverse shell payload for you. If we go back to our browser quickly, I'll show you what that does. The code is just slightly different, right? So we have this varnet, we're requiring a network protocol, we've still got child process, and then we're going to do child process.spawn, and we're going to spawn a shell, and then we're going to start a new network socket back over to tcp.ngrok.io on a particular port. So in this case, 12345. And then we're just going to open up that pipe, and then, yeah, this is going to give us a nice thing. Again, I just encoded this as hex, turned it into some reverse shell thing, but I created a script that does this all for you. This is even easier than the last one. We just go /gen reverse payload, we do -p, and then we pass in the port that we saw in ngrok. So this is the port here, right? So this is what my machine's looking at. If I hit enter on that, this looks very similar, except what this is going to do is going to do the different code, which is going to open a TCP connection. So if the demo gods are with me, I can copy that, go back to my postman here. Let's change Bob's name to Jude Harris. There we go. Why not? Still got Sally's email address, but anyway. And if I paste that shell in there, or this code in there to do the reverse shell, hit send. Thanks for your details, Jude. Everything's working fine as we expected. But if we come back to my netcat listener here and run ls, boom, we have a reverse shell. Now I'm logged on to the underlying host for Azure Functions. So from here, you're basically screwed, right? People can do whatever they want, right? We can go to we can go into the add speakers. We can list that. We can do a cat index.js. We can actually look at the code for add speakers. We can start looking for vulnerabilities here, right? We can see, oh look, const admin pass equals super secret password. I wonder what that will get me access to. We can do an env. We can see all the environment variables. We can do like env. And if you know Azure, you know that it uses connection strings. So I'll like try onnection or something like that. Oh, here we go. We have a speakers table connection string. All right, here we go. Account name. We've got an account key. And we've got, so I can literally just go away from here now, just exit out of this shell, use this account name and this account key, and we're off to the races. I've basically now got access to a storage account in Azure because somebody's left their key in the app settings and they aren't using Key Vault and Key Vault references. What else can we do? Let's have another ls. Where are we? Let's pop back. So, oh, look, what's that there? Look, did anyone notice that? List invoices. What's that doing in there? Oh, what did I talk about? The function app boundary, right? Remember, if you put unrelated functions in the same function app, then one's vulnerable. So if you have two development teams with two different processes running the same function app, you should never have this, by the way, but just in case you were crazy enough to do that, then there is a potential for that to happen. We can also look at things here like the one directory we're allowed to write to in Azure Functions, and also in Lambda and others, is the /temp directory. So we can list out the /temp directory. Oh, what's happening here? It looks like we're writing data to /temp as part of our function. Let's have a look what that does. You can't tab anything out. Oh, look, so we're just printing everybody's data into /temp. So we can see Dean, we see his name, his surname, his email address, and we're storing it in /temp. That directory /temp is great to use, but also just be aware of what you're putting in there. Other functions do have access to that. Other invocations of your function have access to that as well. I've actually found that this actually doesn't die as quickly as this connection dies. So I've been doing some testing, and this connection will die probably about 8 minutes in. I can have a shell for, and it will cut me off. but the files actually tend to stay there for a number of days actually, and it actually depends whether that underlying function host gets. I spoke to the functions team about it, and they said it just depends whether that host gets reused or not, right? Because if it's still available, then we'll just use it again for you next time, in which case your files still kind of hang around. So they can stick around for a little while. So there's a few things we can see here, but basically we have underlying. I've cancelled out that now. We have, and I'm going to cancel my ngrok for. I'm on the internet. People can just like now start connecting to my machine. So I'm going to stop allowing people to connect to my machine. But let's have a go back a look at the slides and see what we were able to achieve and what we were able to do, right? So what are our findings? I'm going to try and prioritize these in a way that we would do in a testing report or something like that, so we can see based on priority what's going on. So first of all, there was remote code execution. This comes down to AppSec, right? We shouldn't have been able to do RCE. This is probably the worst class of vulnerabilities, right? You're completely owned at that point. We had vulnerable dependencies. This also falls under AppSec, right? So remember those two things I spoke about at the beginning? We've got code and configuration. Kind of split these out into the two for you to kind of understand. No auth. This is a little bit of config. It's a little bit of AppSec. HTTPS isn't enforced. This is config. We can enforce this in policy. We'll see that in a moment. Managed identity is wide open. We didn't really have time to explore that, but ultimately that managed identity that function has is wide open to the world. You can go and access the entire subscription if you want to. Secrets were stored in plain text. We saw that in the environment variables, but we also saw that in the super secret password variable that was sitting in our code as well. The function at boundary, right? We had our list invoices functions in the same place as the other one. We're also writing data, confidential data, to the /temp directory. And information leakage, right? Right at the beginning, when we sent in a bad request, we got all that information back. That's bad, right? We got the server headers, we got a bunch of information back. So let's have a look at how we could go about fixing these kind of things. So I'll step through them all, and I'll be as quickly as we can to get through this. But remote code execution, right? Input validation is really your friend here. Any external input that comes into your application, you should be validating it. This isn't a serverless thing. This is an AppSec thing, right? A web application file can help you here to detect some stuff. But also you should run a web vulnerability scanner against your app, right? OWASP Z attacks proxy is 3. You can do that as part of Azure DevOps or pipelines as part of your build process. That will find simpler injection vulns for you. It's not the be all and end all, but it is pretty good. It's got the, I think somebody ran it on like OWASP Juice Shop, which is like a super vulnerable web application. And I think it found like 30% of the vulnerabilities or something like that. So it'll pick the low hanging fruit and all the simple vulnerabilities for you. There's others available here as well, but also not only a web scanner, but like a cloud config scanner, something like Cloud Suite or Prowler on AWS or something like that. I can show you the WAF actually, just super quickly. Basically what I'm doing here is I'm using a WAF built into Azure Front Door, and then I'm only allowing the WAF to access my function. So Azure Functions has something called a function key, and you can decide whether your function can be triggered anonymously or with a key. So here I'm going to say my function can only be triggered with a key, and then the only thing that has that key is my front door, my basically my entry point into my thing, which means it's going through a WAF. If somebody tries to bypass the WAF and come straight to my function and they don't have that key, not allowed. So we can actually see that I have a web application file running here, like an Azure Front Door. And then if I click into the web application firewall and look at the policy, you'll see there's a whole number of managed rules that we can use here. They're out of the box. But sometimes it'll catch simple injection attacks. There will be some remote code execution stuff here, Unix commands and stuff like that. They're configured to block. But you can also create custom rules really easy. I actually created a custom rule for this specific vulnerability. Imagine have that conversation with the developer and they say, oh, I'm really using that node serialize module, Dean. There's no way I can get rid of it, or I can, but it's going to have to be in a few sprints or something like that. You could build a custom rule for that. You can just say enable the rule. It's a match rule. I'm going to say if string in the request body contains $$ND. This should look familiar to all of us. Then we're going to add a new condition. We're going to just deny the traffic. And we can actually see that in action. If I go along to my front door request here, so I'm actually now going to serverless-security-demo.azurefrontdoor.net. If I then send this bad request in there, I get a response back of a 403 forbidden. Naughty, naughty, behave yourself, Dean. So yeah, we're not allowed to do that. This is standard. You should always return this when you do when you send a 403 back. So if we head over to the so we've got the WAF application, we can run a WAF there, right? Vulnerable dependencies, right? You should at least run npm audit as part of your build if you're using Node, right? You can use commercial tools like White Source or Sneak. One thing that's crazy is that like this, everyone's run like npm install, right? Every time you do this, you get this tiny little line that says found one critical severity vulnerability, right? Yeah, are you actually going to find that or not? Are you going to see that? So as part of your build process, you should be running npm audit. No auth, right? We should use function keys, like as I just said, with front door as a minimum. So your API gateway, or your front door, or your logic apps that are connecting to your function can only access them with a function key. But also if you've got user authentication on your apps, you should use Azure Auth with Azure B2C, so business to consumer. So here's an example here using sideways requests from API management to Azure Active Directory to request and validate tokens for a serverless-based app. The other thing is that HTTPS wasn't enforced, right? This is really important. You can turn this off. You can go and turn it off. Annoyingly, it's actually not turned off by default in Azure Functions, and I've raised this as a feature request to the team. But you can also enforce this with Azure Policy. So you can set a policy that says here that the field HTTPS only can't be false, right? That must be true, right? So you can build policy in so that when people try to create or update resources, it will fail based on your policy. And again, you can implement these policies into your build. There's a theme here about implementing DevOps, and that makes things a lot safer as well. Manage identity being wide open. We should use least privilege access, right? This is really important for us to do. We should make sure that we're using least privilege where possible. Our function should only access what it needs to access. Some people would say to you that you need the function to you should use built-in roles within Azure. I actually disagree with that. I think where possible, you should use custom roles. There's a little bit more management overhead, but at least it means you know what your function can only access what it needs to. Here you can run this command, AZ role assignment list, pass in the assignee from your function. So this is the role that's assigned to your function. It will tell you all the assignments that function has, and you can check it out and see if anything's unsecure. Secrets are stored in plain text, right? So we should store our secrets in Azure Key Vault. And in app settings, we saw that one in app settings there where we had the storage connection string. We should use Microsoft Key Vault references. So this is a bit of an eyesore, but you just do @Microsoft Key Vault and then secret URI. And this is the actual URI of your secret in here. And then it will just go and access that parameter. Will you just reference it in your code based on the parameter name, and it will go and do all the magic under the hood of getting the keys from Key Vault for you, as long as you've got an identity of access to that particular vault. So much, much easier. And the function app boundary, right? Our function app share identities, application settings, and underlying host. The other thing they should share is a deployment endpoint, right? So if you're letting multiple people deploy to an Azure function app, right, they share that at the function app level. They share a temp directory for the life of the instance, and they also share a scaling boundary. That is the unit of scale for your function. So bear that in mind from a security perspective when you're building out these apps. And information leakage, right? We should do proper exception handling, right? Binding to uncaught exception. Don't ever return error.stack, which is exactly what I did there, and you saw the stack trace come back. Don't ever do that. But also override the default headers with your own values. We saw that Kestrel header that come back there. You could just do this in your response within Azure Functions. Here you can see I'm changing the server name to Billy Bob. So that's kind of a summary. But one thing I want to talk about is, wait, what if my function isn't triggered by HTTP? This is something that I find fascinating. I don't have all the answers for you, so sorry if you've come here for that. But I think it's something that we should explore, right? What if your function isn't triggered by HTTP? Because as you'll see, probably, I'm guessing in Steve's talk, where he's talking about a bit more around serverless automation, things aren't going to be triggered by HTTP, and it's a very common use case to not do that. So how do we secure them? So some things won't work, right, or don't matter. So a web application firewall isn't going to work, right? All your requests aren't going to be routed via a web app firewall. Arguably, a web vulnerability scanner isn't going to really work because it doesn't have a web endpoint, right? We're triggering it from a blob, an item being added to blob, or an event trigger or a queue. HTTP or HTTPS doesn't really matter, right? We're not triggering it via HTTP, HTTPS. We don't really care about that. Information leakage doesn't really matter-ish, but it does matter a little bit. You should always not leak too much information especially if you're passing data on to other things off the back end. But in terms of back to the caller, it doesn't really matter because you're kind of trusting the initial requester, be that your event grid or whatever. But lots of things still do matter, right? So vulnerable dependencies still matter, right? Managing our keys properly matter. Input validation really matters because data is still coming in, and most security practices still matter when our functions aren't triggered by HTTP. So, and this is something that I've been doing a little bit of research into, and I want to do some more work in, but really to think about how do we go about and secure these functions, because I find that a lot of people just take it for granted. They say, oh, my function's being triggered by blob storage, right? I don't need to worry about all this stuff, or my function's being triggered by a queue that I own and control. But at some point in this pipeline, if there's user data coming in or input, then you could potentially be vulnerable if you don't adhere to best practices. So some attack scenarios, right? An email trigger. They don't support this in Azure actually, but in other cloud providers, you can do an email trigger. What if the email trigger comes in and you're relying on the email being from dave@dave.com, right? Seen people do this. Someone spoofs dave@dave.com. All of a sudden, they're accessing your system, right? Because you trust that it's a trigger coming in from SES or some kind of event email service that you control. Blob trigger, file name injection. I've seen this quite a few times, actually. You can upload a file with a file name. See those commands we were just sending in for that remote code execution thing, right? If that was a blob trigger and we could upload a file with a name that was like ls or env, grep, msi, right? We could actually just upload that and have it do something, right? Again, code injection through queue and event triggers is another thing. Blob triggers, file upload vulnerabilities, right? Things in like XML, PDF, XML external entities and things like that. One thing that's quite interesting, and I'm not really sure on this, the answer to this, is the database change feed triggers, like Cosmos DB change feed, right? If something malicious has got into any field in your database somewhere, and you're triggering a function off the back of that database change for every single update, and then getting that data into your function, if you're using that in an insecure manner and you're not validating that input, potentially you could be insecure there as well. So a lot of these we can fix by writing secure code and doing things like that. But what I really am keen to explore further, and this is kind of an open conversation, is how we can test for these vulnerabilities for non-HTTP based triggers, right? So one thing that we can do is we can do manual invocation. People might not realize this, but you can manually invoke your Azure function if it doesn't have a HTTP trigger. You have to use the /admin/functions API, and you need to go and get your function key, the master key for your function, and pass that in as the X functions key header. So this gives us some ability here that we can then hit all those endpoints and scan them. We could try a web vulnerability scanner against these endpoints. There is a bit of jiggery pokery to do there. You need to go and find out what all your functions are, and then you need to go and get all of the host key, the function keys for your functions, and then have your tool understand how to go and do each one sequentially, because everyone's got a different token, every single function. So there's a little bit of overhead there as well, but there is the ability to invoke manually. So I think this is probably the angle where you'd want to go and start invoking things manually. I know you can do this with AWS with the invoke API. I'm not sure if this is possible in GCP or not. But yeah, so I think this is the way to go. But also, when you think about these type of triggers and these type of events, a typical web application vulnerability scanner might not work because they're expecting a particular schema of an event, right? Say we're using Azure Event Grid and we're triggering a function, then the schema that goes into the function is like a standard format, right? We know what that is, right? It's always the same. So it's probably, you want to put the payload in like the data field or like the subject field or something like that, that is likely that somebody is going to actually use in their code, right? They might not be using others. So I think there's more work to be done here, and I think there's a massive gap in the serverless security market for some kind of tooling for this. So a kind of call out to help, right? Want to help? If anybody's watching this and they want to contribute, I'm looking to build some open source tooling around this to see if we can build some kind of tools for testing these kind of functions that does some of that automated, like get the functions, get the keys, and then understand the schema of like Event Grid, for example, and then try a payload in every single one of the variables, right? And then do the same for the next one. Maybe we could even use serverless to build it and run it as a timer-based function, right, on a thing, and just have that hit that at your account. I'm looking to dive into this and explore some tooling around how we can do it. So if anybody's interested in this space and wants to help contribute towards that, and I see Mark's putting his hand up. Yeah, yeah, I'd love to collaborate and build some awesome tooling to help this, because I think it's something that people take for granted, and I think there's a big opportunity for us to make developers' lives easier. So 5 key takeaways here quickly for me to wrap up is that AppSec is AppSec. It's still relevant in serverless. Be mindful of non-HTTP invocations. Just spoke about that. Adopt least privilege principle. Adopt push left and DevSecOps, right? All of this. I spoke about. Add this to your build process. Add this to your build process. Do this in an automated fashion. Implement Azure policy for config to check that those configuration things are right. And use Key Vault for all your secrets. And yes, I know there was actually 6 takeaways there. So that's kind of it from me, and I'll pass back to the team. Thank you so much for listening. I'm Dean Bryen. You can hit me on Twitter @Dean Bryen. I'd love to continue the conversation and here and in Discord as well if people have got questions and stuff. And I think we'll be back later for questions anyway.
Awesome. And Dean, if they want to contact you for joining your project, is Twitter the best way to go, or do you have other channels to share, or will you share those in Discord?
No, Twitter's best. Hit me up on Twitter. My DMs are open @Dean Bryen. Yeah, that's the best place to reach me at.
Awesome. Thank you so much for this talk. I mean, I was laughing, but also scared at points. So I think it's a good moment to use the break to check on a couple of things. And so thank you so much. I think we're going for a little break, and then we'll be back with your brother. And then after Stephen's talk, we'll have a Q&A with both of you. Thank you so much. welcome back everyone for our second talk of the evening, after which we'll have a Q&A. So I want to just remind you to go to Discord and make sure to ask all of your questions for Dean and then also for Steven in Discord so that we can have a nice conversation with them. Otherwise, you'll just have to entertain all of my questions, and there are plenty especially after the last talk. It's my pleasure to introduce the next speaker, Stephen Bryen, related to, obviously. And after a short stint at Microsoft as the head of solutions architecture, data, and AI, Stephen rejoined Amazon Web Services as a senior technology evangelist. And he's the other half of the Cloud Security Meetup London organizing team. Guess who the other half is? And Stephen's talk will be about securing with serverless, and focused on demonstrating how you can use serverless technologies to secure your cloud resources. Using serverless tools to implement security automation is cost-effective and scalable, as we all know. And we will discuss why you should do this, what tools are available, and dive into some of the demos of different ways to use serverless tools to automate cloud security. So Stephen, take it away.
Cool, thank you very much. So hello everyone, thanks for having me. I was actually just saying, it's funny that we run a meetup in London where we had a speaker from Amsterdam last night, and now us from the UK and near London are on your meetup in Amsterdam. So great to be here. And what I'm talking about today is securing with serverless, and in a minute we'll get into what this talk is and what this talk isn't. But as was just said in the introduction, I'm Steve Bryen. I'm in AWS Developer Relations, and what that means is that my job is to share the best practices and love of AWS with the technology community, and help you get the best of the platform from a kind of peer-to-peer perspective, talking with developers and engineers, not necessarily at you. So my Twitter details are there. As Dean said, you can reach out to me as well, and we'll be around for some Q&A afterwards for people that are live on the stream. So I guess firstly, this session is not how to secure your serverless apps. So Dean was just talking about how to secure your serverless apps in the previous talk. But I wanted to take a different twist on serverless and security, and look at something a little bit different. Because if you go to Google and search for serverless security, you will find tons of content available around how to secure your serverless apps. You'll find things like the OWASP Serverless Top 10. Dean referenced this in his talk. This is a fantastic resource for you if you're looking to do AppSec in a serverless space. You'll find blogs from industry thought leaders like the serverless.com team on how to do security for your serverless applications. You'll find companies like Sneak, also someone Dean mentioned, that will help you do serverless best practices. But all of this content is about how to do secure your serverless apps, and I want to take a different spin on that. I almost thought I found something in my search results that was what I was presenting about, and I found this from the actual UK National Cybersecurity Centre. So this is pretty cool that our government here in the UK is thinking about cloud security with serverless. It's a pretty cool thing to think about. And I read this headline, I thought, there is some content out there doing what I'm trying to do. Cloud security may be easy with serverless. However, this talks about the fact that the attack surface for serverless is much smaller and doesn't necessarily solve the problem that I'm trying to talk about either. So what this session is how to secure your cloud resources using serverless tools. So how can you use serverless services that we all know and love to actually implement security in the cloud? So I know what you're all thinking. You're thinking, that's DevSecOps then, I know all about DevSecOps. That's one of the key buzzwords in the industry right now. It's right up there with shift left in the security space is one of my least liked words. And you all think you've kind of sussed me out and you know what I'm going to talk about. And you may think after this talk that it's a DevSecOps talk. But when I think about the word DevSecOps, this is what I think. It makes complete no sense to me whatsoever. And every diagram you see I encourage you to Google image search DevSecOps, you get this picture of a DevOps pipeline, and then they kind of draw a red line around it and say security, and that's apparently what DevSecOps is. So to me, that term doesn't really make much sense and doesn't really resonate with what, or is not very self-descriptive of what we mean when we talk about things like DevSecOps and implementing security automation at scale. Really, what we should just call it is cloud security automation, and that's what we're going to talk about in this session, is how can you automate cloud security at scale. And I'm going to use AWS, of course, being an Amazonian, to demonstrate some stuff shortly. But generally, the concepts here around using serverless security could apply if you're using other cloud providers as well, I'm sure. Although I'm not too familiar with their products. So why serverless? And you look at the 5 things I have on the screen here. These are things that you know. You're on the serverless meetup. You're aware of serverless, so you know that these are the benefits of serverless technologies. Firstly, you rarely or mostly never pay for idle in terms of your serverless resources. So this is a great benefit for doing security using serverless, because then you're only paying when an event is triggered. You're only paying for that remediation to take place, or that analysis to take place when an event is triggered, or when some kind of security finding takes place. Of course, is event-driven, which works really well, both from a reactive security perspective. So, reacting to an event is obviously a common use case that we're going to see here. But another use case is to proactively think about security. So how can we proactively run serverless tools to maybe every 5 minutes, every 10 minutes, to proactively search for things or look for vulnerabilities or other things in our environment. So event-driven is useful both from a reactive and a proactive security perspective. Of course, you get the benefits of serverless, that it's scalable, it's highly available. So all that stuff, those kind of architectural best practices are built into how these serverless tools are built in AWS. And as always, serverless is much more opinionated, so you have less ops overhead, the kind of stuff Dean spoke about, that actually using serverless to secure your serverless apps means that your serverless security automation is inherently more secure itself, that you don't have to patch it and operate it as you would like an off-the-shelf piece of software to run on an EC2 or a virtual machine. So generally the benefits for serverless for security are the same as your general serverless benefits all up, but a little bit of a twist there from a security perspective. So when we think about security, and apologies for the kind of logo storm here, these are a bunch of AWS services, but we'll talk through them slowly. When we think about security, and we identify and detect, report and respond and analyze security events, we're just focusing on these kind of 3 key areas here, that we're going to demonstrate how we can detect security events, report on them, and then respond to those events using some other action. So if you look at the diagram here, you can see that in an AWS world, we have various different services that allow you to detect and identify security events in your AWS account. The first one is CloudTrail, which is a service which logs AWS API calls. It is the kind of who, what, where, and when of what happened for API calls into the AWS APIs. And then we have CloudWatch, which has a login feature, CloudWatch logs. So obviously you can capture tons of logs there, and then you can apply metrics and metric filters to those logs, and then trigger events based on specific patterns being matched in your logs. This is typical log analysis type stuff here as well. You can also trigger on some kind of a metric as well as custom metrics that you can use CloudWatch for as well. We have this really fun service called Guard Duty, which is and I don't want to market you these products, I'm just outlining them so when I get to the demos, you know kind of how they work in the equation. Guard Duty is like a machine learning intelligent intrusion detection service. So it looks for key patterns and behaviors in your logs to identify you on potential security risks. And then services like AWS Config, which tracks for changes in your AWS environment and makes you aware of them. And obviously many other portfolio of security services, as well as third-party tools that can help you detect and identify security incidents in your environment. But once you've detected that, you need to report it. You need to send that event somewhere once you've detected a security incident. So in AWS, we can do that manually. Well, we report it automatically, but we can respond to it manually or not. If we want to add it as a finding in something like Security Hub, this is a centralized dashboard where we can look at security findings in our AWS account. So Guard Duty alerts, for example, show up there. Or we may just choose to send that event directly to some automated remediation action that takes place using one of these many serverless tools over here on the right, whether we send that to Lambda to execute some custom code, or we store that event in S3 using Kinesis Firehose or something. So there's tons of, for these kind of events, you have the trigger and then the target. So on the right hand side of the slide here, you see the many targets that are available for tools like EventBridge. EventBridge is just an event bus service, pretty straightforward service, scalable event bus service. It previously was called CloudWatch Events, and CloudWatch Events still exists. So I'll show you that in the demo. They're basically the same product under the hood, but the previous implementation was called CloudWatch Events. So if you hear the term CloudWatch Event used when you're researching around event-driven security in AWS. EventBridge and CloudWatch Event can be used interchangeably. EventBridge just adds a few additional features like third-party integrations and custom event buses as well. So I don't want to spend too much time on the slides. What I want to do is get to some practical examples and get into the console and show you how I've set up a few serverless security triggers. So what I'll do is I'll show you a demonstration of what we're going to do, and then we'll get into the console and run through it. So in this example, we're doing a user initiated automation. So there's some automation that happens before the user gets involved here. These are just general tools that we've turned on in AWS. So in this environment, what I've got is I've got a group of EC2 instances. Sorry, serverless people, this is some servers that are running, and this is what I'm kind of monitoring for security incidents on. So they're just running there in the environment. And what I'm using here is I've turned on Amazon Guard Duty. So all the logs, the VPC flow logs, CloudTrail logs, and DNS logs are being consumed by Guard Duty, and it's using machine learning to create findings for me based on what's happening in that EC2 environment. And they get sent to Security Hub in my findings report, which we'll see shortly. And then this is where the serverless kind of part comes in. What I'm going to do is create what's called a custom action, and my security operations user can then look at a finding and take an action on that finding based on what they see. So this is a user-initiated, a human-initiated automation, but using EventBridge and Lambda to do something. In this case, what we're going to do is isolate that EC2 instance because we see some kind of bad traffic coming towards it. So I'll head over to the console and we'll walk through that so you can see how that builds up in practice. So I'm over here in the AWS console and I'm in Security Hub. Please ignore my low security score here on my Security Hub findings. I apologize for my lack of security in my demo account. But what we're going to do here is firstly, we're going to go, what we want to do is we want to create a custom action so that when a finding comes into Security Hub, we can go and trigger that custom action as a user. So we do that in the settings over here. We go into our settings, we can see custom actions. Now I've already created this custom action, but I'll show you what it looks like. It's super straightforward to set up. You give the action a name. This is the name that shows up to the user that's going to trigger the action, a description. You also give it an ID. I'll show you when we create an action, we give a custom action ID. In this case, mine is called isolate instance without the space, so no spaces in the ID. It becomes part of the resource name, the reference that is unique to that instance there. So we have this isolate instance on here that we can use. And what happens is when someone triggers this custom action, it sends an event to Amazon EventBridge. So Security Hub is integrated with Amazon EventBridge, and an event comes into EventBridge that we can then decide to action or not based on a rule in EventBridge. And what we look for is this specific custom action on EventBridge. So if we head over to EventBridge here, you can see that I've got a rule here called Security Hub Isolate. And what this is a very simple rule. When you define a rule in EventBridge, you basically use this JSON syntax to define an event pattern. What an event pattern does is basically all of the events from Security Hub come in here, and then you're looking for you're basically pattern matching in this event pattern. You're saying whatever data comes in to this event bus, if it matches any of these JSON attributes, then trigger this rule, trigger the targets that are associated with this rule. So what we have here, Security Hub's integrated, so we know that we get a source from AWS Security Hub. That's where the event's coming from. We know the detail type is that we want a custom action, and then we want to specifically trigger this rule based on, or trigger this targets for this rule based on this this ARN of this isolate instance action. So this EventBridge rule is made up of two things: the event pattern and then the targets. The target here is a Lambda function called Security Hub Isolate. Based on this matched event. So based on this matched event, we will trigger a Lambda function. So let's go and look at what this Lambda function looks like. So we can look at some code now. And I'll just zoom in a bit here. Hopefully that'll help. I'm not going to run through this line by line, but it's a very simple Lambda function. What it's using is that it's written in Python. It's using Boto 3, which is the Python SDK for AWS. Boto is apparently named after a dolphin that is in the Amazon or something. I don't know where that came from, but it was an open source project that we inherited as the SDK a long time ago. In this, what you see here is we have an environment variable in a function called our security our securities SG, which stands for security group. Basically, this is the security group that we're going to put our instances into to isolate them. This is for those that aren't AWS people, a security group is an instance level firewall rule. So this security group specifically has no rules, no access, whatever to it. So we're completely isolating it from the outside world. And then just a bunch of stuff here without running into detail, where we're basically going to say for move our instance, EC2 client, modify instance attributes into this security group, basically. So we're going to take this EC2 instance, the ID is going to come from the security hub finding, and this Lambda function is going to take that information from the event and go and use the EC2 API to move that instance into an isolated security group. So we've kind of walked through how we set up that serverless thing. I'll just go back to the demo, the slides to show you what we did there. So we've created a custom action, which isn't highlighted here, but in Security Hub, we've created a custom action here. It triggers an event, and then we create an event bridge rule, which when that custom action is triggered, the event goes to event bridge. If the pattern is matched, we then trigger a Lambda function, which isolates that EC2 instance. I think if I click here, you even get a nice little no entry there on the slide. So that's what we're going to do right now. So let's take a look at our EC2 environment. I apologize that we're looking at EC2 on a serverless meetup, but what can we do? So I've got a bunch of EC2 instances here. We're going to look at this one specifically when it refreshes. And this is a Bastion host. It's a Linux host. You can see it's in this security group, this guard duty simulator Bastion security group. This is a open source project that it's a cloud formation template you can spin up in AWS. And what it does is it simulates a bunch of security attacks, so you can test guard duty. So this is a kind of simulated environment where I'm simulating some threats in my AWS environment. So we go into Security Hub and we go into our findings now. We can see there's a ton of findings in here. Security Hub's doing all these checks. I'm just going to add a filter here on product name for guard duty. Product name in here, guard duty, just a filter here. And you can see there's a ton of events here that have come through from guard duty. This one was 16 hours ago, that someone was performing SSH brute force attacks against my instance. Now that's pretty concerning. Someone was performing SSH brute force attacks. So we'll just check this instance ID 7B9DC. That is my Linux Bastion host here. That's pretty concerning. Someone's making brute force attacks against my EC2 instance, which is my Bastion host. This has potentially got access to everything in my AWS environment. It hasn't, it's a simulation, but let's assume this is a real world environment. I can select this incident, and now I can go to actions, and you can see I have this custom action up here. And when I click this custom action to isolate the instance, it says successfully sent the findings to CloudWatch events. If we go into Lambda here and we look at our monitoring, we should see that this Lambda function was triggered successfully. No, not yet. All right, it might take a while to update the metrics. But we should see that this EC2 instance has moved to a new group. You can see down here the security group isolated hosts. So all I've done here is, as a user, I've said, this looks concerning. I need to take some action on this as a SOC user, or someone who's in the SOC, SOC analyst maybe would do this. They've looked at Security Hub, they've found their findings, and they've triggered this isolate host action that sent the message to Event Bridge onto Lambda, and I've now got this serverless user-initiated remediation where I've isolated my host using serverless tools. So pretty nice setup there. So the second demo I want to show you is a fully automated remediation. So in this example, what we're going to do is a user is going to create a table in DynamoDB. So for those that aren't aware of AWS or Dynamo, Dynamo is a scalable NoSQL, fully managed NoSQL database. At the basic level, there's much more to it than that, but just keep it at that for the sake of this talk. What the user is going to do is create the DynamoDB table. Now, a cool thing about DynamoDB is I'm not actually able to create a DynamoDB table without some level of encryption. But the default level of encryption is an AWS managed key, and that's perfectly fine for most use cases. But I want to enforce that my users are actually encrypting with a customer managed key, a key that I have control over. And that key is going to be stored in Amazon KMS, key management service. So what we're going to do here is use a different set of services that basically do a similar kind of thing. So this time we're going to use a product called AWS Config. AWS Config, I touched on this earlier, but I'll just say again so you're familiar. AWS config basically creates a delta of all the changes that happen in your AWS account. So if you make a change to a DynamoDB table, if you create a resource, or if you make an update to a resource, AWS config will have a delta of that, so you can see the diff of what changed and what happened. So that's the kind of general concept of AWS config, and you have to turn on AWS config in your AWS account to enable this. Off the back of that, we'll create something called a config rule. And a config rule is basically a rule that says, if this thing happens, and there's a bunch of pre-built config rules in AWS config. You can also create custom rules as a whole, well-documented process on how to create custom rules using Lambda, actually using Serverless to create those custom rules. And then config rules has the ability to create a remediation, either a manual or an automatic remediation. And we're going to create an automatic remediation which is associated with this rule. This automatic remediation is going to, there's some built-in automatic remediation steps that you can take with config rules, but there's not one for what I want to do. So what I do is I use the SNS as a glue here in my serverless workflow. And that config rule remediation will automatically send a message to an SNS topic, which will then be the trigger for a Lambda function, which will go and encrypt my DynamoDB table with the right KMS key. So hopefully that makes sense. I'll give you a quick run through of what that looks like. So I've got AWS config here. I won't go into config too details, but I have this rule in my AWS config that I've created that says, if it loads, no, of course, AWS config is not working right now. Great. Please load my rules. There we go. So I have this rule called DynamoDB table encrypted KMS. And this is a rule that checks whether DynamoDB table is encrypted with an AWS KMS key, and it's non-compliant if it's not. You can see I've got a couple of DynamoDB tables here that are compliant, and I have an automatic remediation action which triggers if it's not compliant. And this publishes an SNS notification to my SNS topic. So over here I have a SNS topic called remediate DynamoDB, which basically is just a trigger for a Lambda function which is subscribed to that topic. This Lambda function is even more simple than the previous one. It gets the table by its name, which is passed through as part of that event, and then it updates the table with the master key ID that I've specified here in the code. It could be an environment variable, but I'm not focusing on the perfectness of this code for the demo, but it's a unique key for my KMS key here called Steve key. So if I go to Dynamo and I can create a new table, I can call it Steve table 3. The primary key is, let's call it ID. We create that table. You can see that by default, the encryption type is default. And if we just wait a few minutes, this whole process will do its job. And we'll come back to this in a second maybe and just get to the slides, but you'll see that in a second this will update to KMS because the config rule has shown non-compliant. That's triggered the auto remediation by SNS, which has triggered the Lambda function to go and do that. So while that just does its work in the background, I'll just get back to the slides. We should see a KMS encrypted database in a second. So just back to this slide, really it's about using serverless is about detecting, reporting and responding to events. And there's various tools available in the cloud for you to detect. There's tons of data. Actually, being in the cloud means that you're more secure. You get much more data than ever. Just imagine trying to get all this insight that you get from CloudTrail and Config and CloudWatch in an on-prem heterogeneous environment with various different technology vendors. It's almost impossible. So you're actually in a really perfect position to do better security automation in the cloud than you would ever be on premises. And serverless then makes it super easy to have this cost-effective, scalable way of taking action on those security events and then just auditing and governing your AWS environment so you can let your developers innovate and use the tools that they want. I'll just see if that demo has worked just yet. So if I just refresh here, no, it's still default. So we'll see if my, so let's take a look in here. We can see, I think the config's having a bit of fun today. So doesn't seem to be loading everything. We can see resources in scope here. Now config's not loaded yet with my next with my table, but in a second you should see that is encrypted with KMS. We'll come back to it again in a second. I guess one of the key things here is that this isn't just when I create a resource. Config will trigger when I update a resource. So if I have a bad user that goes into table 2 and changes this encryption back to default, config will just kick in and encrypt it with KMS again. So it kind of fixes bad behaviors as well. It's not just for create action, it's for any action. It's for whenever this instance is non-compliant. So I'll just check that table 3 one more time before we come back to it. No, still default. No doubt the demo is not going to work, typical live demo stuff, but I assure you it worked earlier on. So I guess now if you were to search serverless security, you would maybe see this, security, serverless security is not just about implementing security practices at the AppSec level on your serverless functions, but you can actually use serverless to do security. So you may find this Meetup, depending on how good the SEO is on meetup.com. But I guess it does kind of come full circle, Now I can use serverless to secure my serverless apps, right? So you're thinking, this is kind of a bit meta, this is a bit incestuous, right? I can now use serverless to secure my serverless apps using some of these serverless workflows and serverless automation as well. So your minds are hopefully all blown. This talk maybe in some unorthodox, crazy way was actually about how you can secure your serverless apps as well as using serverless to do security as well. So hopefully that that kind of makes sense what I'm trying to get across there, that it's kind of, you can use these tools to secure serverless apps as well as non-serverless apps as well in your environment. And I think the DynamoDB example is a good example of that, given DynamoDB is a serverless database. And just one more time, I'll try and see if this works. Oh, there we go. It's already updated. My encryption type is KMS now on table 3. So just within less than a couple of minutes, my automatic remediation using serverless has gone and remediated that non-compliant resource in DynamoDB. So I don't think there's much more from me. Hopefully a few good practical examples so you can see how to use serverless tools to do security automation in the cloud. And I don't have, my next step on my to-do list is to wrap those kind of demos up in some kind of serverless package using SAM or CDK or one of the serverless packaging tools. And if you follow me on Twitter or reach out to me, I'll make sure they're available to people once I get them out the door in the next month or so, I'm sure. Thank you very much.
Thank you so much. That was a wonderful talk, and indeed mind totally blown. I think you should try and say the takeaway 10 times after each other, and you will not manage to do so without making mistakes. And people, please post your questions in Discord. We have someone wonderful helping us out actually in Discord. Stacey Cashmore will help us surface the right questions and we'll lead all of that. So please, bring all of your questions and we'll discuss those. But actually, after this talk, Stephen, I have one major question: is what does a Bodo look like?
Oh, I have no idea. You've really you've stumped me now. I don't know. Google is your friend, or other search engines may apply for the Microsoft people. Yeah, but yeah, I have no idea. I thought all dolphins were the same. Really, I didn't really appreciate there was various different breeds.
Let's leave that topic.
Right.
Yeah.
Okay.
And welcome to the stage, Mark. Mark, you'll be helping me out with the Q&A round with Dean and Stephen.
Yeah, exactly. And also my webcam feed is not working, so.
Oh, that's lovely.
Yeah. So sorry.
Is my webcam working? Was I on the webcam for that?
No, unfortunately not. So we have some still pictures now of both Bryans and a still picture of me. But Floor is the only one who we can actually see live moving.
It's the only one
lucky you.
Live, so we'll be fine. We don't have any questions in Discord yet, but that's okay. But I think I have some questions, and we can just start out with those. And maybe Mark, you have some questions. Maybe you have questions for each other. I don't know. After seeing these presentations, and so So first of all, like Dean, just for another shout out because you were looking for contributors and people to sort of join your non-HTTP movement. What kind of contributions specifically would you be looking for?
Yeah, just anybody. To be honest, anything. I'm open for ideas. If people have good ideas around how we can tackle this problem, people may come and say, Dean, you idiot, this already exists. Like that would be great. That would save me a whole ton of work.
I think
any way that people can help, right? Even if you're a complete beginner and you want to get involved in learning more about it and you want to dive in, I'd love to kind of collaborate and help. Or if you know this stuff inside out and you have opinions and ideas, then I would love to hear them. And if you want to contribute to building something, then yeah, I'd love to. I don't know if I was building a tool, I don't know what language I would use. But yeah, I'm open to anything, any kind of help or contribution. If it's just like an idea, a chat, someone to throw some ideas at, that's great.
Awesome.
Yeah, because I was thinking, because of course you have had a lot of different runtimes you can use in serverless, but there's of course a lot of stuff on the OS side which you can check. So yeah, I think there's lots of opportunity indeed for people to look into different bits. So either the Windows indeed machines or the Linux machines or more runtime related. So it does sound like there's a lot to be, let's say, discovered.
Yeah, 100%. Yeah, I think there's so much that's like beneath the surface, and it's funny actually when like serverless first came out, and this was, I'm talking AWS Lambda back in 2014, and I worked at Amazon at the time, so I was actually at reInvent when it launched, which was pretty cool. I think you were there as well, Steve, weren't you?
Yeah, I was there.
And like it was this huge announcement, but it wasn't even synchronous. Like it was all asynchronous. Like web wasn't even a thing. Like it wasn't possible. That was like the main feature request. Everyone was like, I want this to be synchronous. Like the first thing, it was all asynchronous, like blob triggers, and every demo on every booth was upload an image and transcode it. It was like using image magic. It was like every single demo was that. And I think a lot of people still use serverless for that kind of stuff. But I still think like the web world, I see a lot more people who are new to it thinking it was like some kind of back-end web API. But there's just so much more to it, as Steve's talk alluded to there, than just web apps, and exploring how we secure them and make them better. Then yeah, I love that.
Yeah, the history is quite interesting, I think, around serverless functions. At least obviously serverless has become a much broader tool set, but I think the history is interesting around that. I think it was originally kind of, I don't think we could at Amazon could anticipate how big it or how fast it grew or how much traction it got. It was definitely more looking at like a mobile backend as a service type thing, triggering, like you say, uploading an image and thumbnailing them and those kind of things. But the use cases have just been exceptional, and as it's integrated with things like IoT and now things like Security Hub and other kind of security is a great use case for it. But beyond that, I think HTTP, I think it was like 6 months after launch before we launched API Gateway. So it was almost like lots of people were using this service. It was super load of traction. Then we added API Gateway, which gave us that HTTP kind of endpoint into Lambda functions. So the kind of beginnings of serverless were non-HTTP triggers.
Yeah. So there is actually a question now.
In the chat. Are you going to take that one?
Shall I read it? Yeah. So question from Rebam6. Great username. Thinking big, do you think it's possible to fully automate the function of your SOC using serverless security tools and auto remediation? I love the idea of relieving our SOC analyst of staring at screens, responding to alerts, and get them writing lambdas and auto responses.
Yeah, I think that's Rebecca. I know Rebecca. She spoke at one of our cloud security events.
Cool.
So hi, Rebecca. I think thinking big, that's a bit of a stretch, to be honest. I think, as with all kind of automation, it's about trust. It's like code deployment pipelines. Before you get to full continuous deployment, you have to build trust in the system. And the key thing, obviously, with security is that you have to make sure that you're not doing automatic remediation on things that are bad, or isolating an instance is a great example. You only want to isolate an instance really when you know there's something bad happening, because you could potentially be stopping a revenue stream for your business, for example. So these are decisions that you have to make as you earn trust in the systems over time. But I think humans play a key part in this.
Yeah, I think also the when you look at things like Azure Sentinel and some of the stuff like that around the SOC analyst. Like there is the reacting to the alerts, but things like Logic Apps. I think AWS launched a service recently that was similar around like no code kind of flow based response and automation. Like Azure Sentinel, by the way, if people aren't familiar, is a cloud native SIEM or security incident and event management solution. And it actually has like native triggers. So any alert can trigger what's called a playbook, and you can design any kind of custom serverless flow using Logic Apps on the back end of that. So and you can use functions there as well if you want, like, but it's natively tapped into Logic Apps. And I see more and more that I don't know if you'd be able to remediate everything. That would be cool. But I think if you could shift the time that people are using from saying like 70% of our time is spent trying to automate stuff. I think that should be the goal, right? Automate all the common alerts that you're getting as a SOC, and then moving from there, start looking at when new anomalies do come up that aren't triggered by the automation, then have a task force to say, how do we then go and automate this, right? And is it possible to build tooling around this?
Yeah, makes sense. Definitely. Yeah. Yeah, I think also a lot of people are actually still struggling to get a good grip on the monitoring and alerting part, which is actually the first step, firsthand, knowing that something is going on. You get any ideas on that?
Yeah, that's hard. Log everything, write good queries for your logs. Yeah, it's especially in the serverless world as well. I'm talking more now around not necessarily using serverless for your thing, but like monitoring serverless apps is quite hard as well. You need real distributed tracing as opposed to just logging, I think, to get real application insights. Log all the things. Everything's stateless these days, right? So nothing sticks around for long. I think that's the first kind of step. Once you've got that out of the way, then you can move on.
Okay, yeah, thanks. Yeah, I think it's especially difficult when you're just starting out and you don't know what to look for indeed. So then the best thing is indeed to log everything. But then you have to still find the needle in the haystack. So I think it's still a challenge.
That's another job that SOC analysts do, right? Depending on the SOC that people are working in, right? Could be like threat hunters would be proactively hunting through the data looking for anomalies. And I'm not sure about in AWS. I'm sure it exists from third-party providers like Splunk and Sumo Logic and people like that. But in Sentinel, for example, there's a bunch of built-in alerts and checks, and they're all mapped to the MITRE attack framework. Which is a framework for categorizing types of attacks. So they're if you're not familiar with that, that's a very good place to start. They're like they're called alerts, but they're basically just queries that query your logs. And if they see a certain pattern, they'll trigger the alert. I think that's a good place to start for people that are really unfamiliar with it.
Yeah, good tip.
Thanks. Yeah, maybe Stephen, you want to elaborate?
Yeah, no, just touch on what Dean was saying about obviously third-party tools available in AWS that do some of that log analysis. Security Hub in itself, we didn't get into it because it wasn't the case of the demo, but has a bunch of pre-built checks for like the CIS benchmark and things like that are actually using config to go and do a bunch of checks on your account for things like making sure you're meeting best practices in your account. So I think the advice really is to just get the basics right, turn on some of those, whether you're in Azure using Sentinel or whether you're using the Security Hub or whatever in AWS, just get some of those basics right, turn on that login and alerting, and then see what you can do with it from there.
Yeah, and for what it's worth, by the way, like Sentinel loves AWS, right? It supports all the AWS logs inbound, has native connectors for them. So even if you're using AWS, you can still use Azure Sentinel.
Stephen, do you approve of that message?
Yeah, actually, Martin, who spoke at our meetup last night, did a talk on Azure Sentinel for AWS. At our cloud security meetup. So yeah, it's great that there's integration across platforms for people that are using, the right tool for the right job, really.
I'm trying to make you fight a little bit, but I'm guessing it's not going to work. That's
We're
okay.
friends here.
Yeah, that's very good. I love that. And actually, on your meetup, can you do a little plug for the meetup? When is the next cloud security meetup?
Yeah, sure. So
can people watch the recording somewhere?
Yeah, so we run every 2 months on the first Wednesday of every month. So I think that means it's the 2nd of September, the next event.
Yep.
We've been running since the beginning of this year. We were in person in London, but we're now online. So obviously that breaks down some boundaries, as you're familiar with. We focus on general cloud security topics. If anyone wants to speak, we'd love to hear from you. If anyone wants to come along, it's at cloudsecuritylondon.com is where you get all the details. That just redirects you to the Meetup page, so it's easy to remember. And you can find all the details there on where we stream and stuff.
I think you still had one question about Christmas dinner talks, right, Floor?
Yeah, absolutely. I just wonder, of course, like at the Christmas dinner table, what are things that you cannot be talking about, right? Or what triggers small family issues?
Well, it's funny because we didn't actually share it. I actually was talking to Mark about this, but we have a third Bryen brother as well.
Yeah.
Who actually works for AWS as well. So we're all in the. It's not a Google, unfortunately. He's AWS as well. Which is maybe
that would have been wonderful.
Yeah, but yeah, we have a lot of kind of tech debate in our family. I don't know if much is off to say. Of course, we have our non-disclosures and there's stuff we can't talk about, but we sometimes get in a bit of a heated debate about features and what's better or what's not, or technology stuff. But we try and keep it peaceful.
We try our best. There's no wrestling on the living room floor or anything, and like over a function app or something. And we both worked together at Amazon for like 3 years or something, nearly.
Yeah, probably, yeah.
And at Microsoft as well, together for a while.
So, do you have any stories from both of those times, like both working together at Microsoft and at AWS, where people were maybe confusing you, which I can just imagine, I don't know, by just looking at you?
Yeah, well, I joined first, so I guess Dean got some kind of confusing looks when he joined Amazon second, and then likewise he joined Microsoft first, and then I got a lot of confusing looks and hellos from people I had no idea. You give them that kind of kind smile as if you know who they are, but you've got no idea who the person is who's just said hello to you. And quite a few awkward discussions of I think you mean Dean. I don't know about you, Dean. Did you?
Yeah, my first day at Amazon, actually, I turned up and a guy there, Chris Heyman, his name is, I walked up to the desk and he said, "Oh, when did your brother join?" Yeah, that was the first thing. Thought he was talking to Steve, but it's funny. People used to confuse us so much that they created an email alias to send to both of us. So like if you got confused who you spoke to, like in the lobby, you could just email the alias and it would automatically send it to both of us. But it didn't last very long because the alias, which I won't share, unfortunately was very similar to an alias for a senior leadership team at Amazon. And a few people got messages that were like joke messages about who someone saw in the lobby who were quite senior. So that got shut down pretty quick, but it was a great idea. It worked. It worked when it worked.
I love that. Yeah.
That's a wonderful story. Absolutely. And anything similar happened at Microsoft?
No.
So I think for something I've had a similar thing where my previous manager at Microsoft, he has a twin brother as well, and they both work in the Dutch subsidiary. And so oftentimes I would like greet the twin brother very warmly, where not knowing that I was speaking to the wrong brother. And I think I've made that person feel uncomfortable at one or another time. So I can just imagine that you two had these similar stories.
Yeah, as a twin, you kind of get pretty used to it. I'm used to people finding me on the train because we live very close to each other, like the train to London. "Hey, Steve, like, how's it going?" to me, and then like complete wrong person, and then you have to have that awkward conversation. "Oh, you must think it's my brother." I had a guy at a wedding once buy me beers all night, thinking that he spent the evening with Steve at a stag party, and I never went to the stag party. And Steve didn't go to the wedding. So, because he couldn't make it or something. So this guy, he would not believe me when I told him that I wasn't Steve. And he bought me beers all night. It was great.
Yeah, I've had that a few times where people just won't believe you. No, you're just winding me up. You're not. You are Dean, aren't you? And people just think you're on a complete, joke with them.
It makes it worse when you have a friend who thinks they're smart and they come over and go, "Oh, he's not trying to pull that one again, is he?" And then nobody believes you.
Yeah. Oh, wow. It's amazing, guys. I love it.
Yeah. If only there'd be an AI that could, differentiate between the two of you.
Yeah, well, I did build a demo on that. I did build a bot that used Amazon recognition, the face recognition technology, to tell people if it was me or Dean. It was pretty accurate as well. I actually didn't manage to trick it yet, although I don't use it too often. But it's more of a kind of fun demo for a talk. And it seems to work pretty well. If you train the AI to know both of us, it seems to be much more, obviously much more accurate than saying if something isn't Dean or isn't Steve, if that makes sense.
It does make sense. And so twin security is a whole new product line, I think.
Yeah, exactly. It's a whole unexplored area I think. Yeah.
Yeah, I don't know if there's enough twins for it to be like feasible, like worthwhile.
True.
Well, that's where you open source it, no? So.
Yeah, good idea.
Great. So
that'd be nice. Like
next meetup talking about this, right?
So people are cloning the twin GitHub repo then. That makes a lot of sense.
Good one.
Yeah.
I like that.
Cool.
Wonderful. Mark, did you check if there's any more questions in the?
No, I don't see any questions here in Discord. I also don't have any questions anymore. So I would like to thank you, gentlemen. This was a really fun session. Unfortunately, a bit too much technical issues. So I think next time we'll make some changes there on technical field. But yeah, thank you so much for participating and having this very nice combined Q&A. Thanks for your technical insights and also the nice twins insights. Yeah, it was really fun.
Yeah, no, thanks for having us.
Yeah, thanks for having me too.
What's next, Mark? Is there going to be a little networking-y thingy in Discord following this?
Exactly. If people still want to hang out and ask questions or give some feedback, please do that on Discord. I'll also be there, and maybe indeed Dean and Steven. Maybe if you could make some time available, that would also be nice. Or indeed contact them on Twitter. But indeed, we'll stop streaming and we'll continue on Discord for whoever wants to. And I think the next meetup will be in September, as we're going for a short summer break. So we'll announce the exact date later.
Absolutely. Thank you so much.
Yes, thanks everyone.
Thanks all.
Enjoy your